Good day, grade 8 students. So for our next topic is going to be perimeter and area of polygons. So you already been acquainted with the perimeter and area of different types of polygons. Okay, so for solving for a perimeter, always just remember that we're getting the or solving for the sides. Okay, so for the side measurements, and also we're going to try to find the sum of the side measurements that we have for our given figure. And whereas for the area, we're trying to get the measurement of the entire space that a certain polygon has. So let's jump right ahead to a problem. So our first problem is going to be about triangles. So Mount Protasio has a square rice field which can be labeled as square salt. One of the side measurements of the square field is 9 kilometers, okay, and Mount Protasio wants to determine the perimeter of the triangular fields, ALT and SAT, when he divided it. Okay, so we want to find the perimeter of this triangle right here, ALT and TSA, or SAT or ALT. So how do we do that? So the first property of a square that we know of is that all of its side measurements are the same. So that means that AL, SA, and ST also has 9 kilometers. It also measures 9 kilometers, 9 kilometers, and also 9 kilometers. And therefore, we have here an isosceles triangle because they have the same side measurements. Okay, so to solve for the diagonal, we're simply going to use the Pythagorean theorem. Okay, so the Pythagorean theorem states that a squared plus b squared is equal to c squared. But since the side of our a is the same, since it's an isosceles triangle, then we can simply write that as a squared plus a squared is equal to c squared. So that will be 2a squared is equal to c squared. Okay. Now we don't know the value of c here, but what we do know is the value of a. Okay, the value of a is our side measurement, so that's 9 kilometers. So that's going to be 2. Okay, it's going to be 2. Okay, 2 times 9 squared is equal to c squared. So 9 squared is going to be 81. Okay, so it's going to be simply 81 times 2, okay, is equal to c squared. And what's 81 times 2? That's 162 is equal to c squared. Okay, and then if we take the square root of both of these sides, so the value of c squared is just going to be c is equal to 9 square root of 2 kilometers. Okay, so the side measurement of c here, or actually side this variable c, the variable c is the measurement of side or the diagonal TA or AT. Okay, so TA is equal to 9 square root of 2 kilometers. And if we add that, if we want to get the perimeter of ALT and SAT, since they are congruent, so that's going to be 9 plus 9 plus 9 square root of 2. So where did this 9 come from? So those are the bases, okay, the basis of our angle. And the hypotenuse or the diagonal measures 9 square root of 2. So the perimeter of SAT and ALT is 18 square root of 2 kilometers. Okay, for our second problem, we have here a memorabilia box, the top view of a memorabilia box that's been inserted inside a cylindrical can. Okay, so this is the top view of it, and the measurement of the radius of the can, of the cylindrical can from the top view is 5 inches. So we want to know the perimeter of the square given the radius. So how do we do that? If you guys try to rotate this 5 inches here, so this could be also 5 inches, right? So that's going to be, if you rotate that from here, it's going to be 5, and that's also going to be 5, and therefore the diagonal of the square is 10. So we solve for the diagonal of the square. So we want to know now the measurement of the side. So how do we get the measure of the side? Again, we try to use the Pythagorean theorem. And again, we have here isosceles triangles since all of the side measurements here of the square are the same. Okay, so what are we going to do here? We're going to create a formula. So that's going to be, since we know that the diagonal now is 10, so that's going to be, we're going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. And since it's an isosceles triangle, so that's going to be 2a squared is equal to c squared. And again, the value of our a here is the one that's missing, the side measurement. But we do know that the diagonal, the long part, or the hypotenuse, or c, measures 10. Okay, so it measures 10 units, or 10 inches. Okay, so that's going to be 2a squared is going to be equal to 10 squared. Okay, so that's going to be 2a squared is equal to 100 and divided by 2. So that's going to be a squared is equal to 100, and the value of a, when you take the square root of both sides, is going to be the square root of 50, or a is simply 5 square root of 2. Okay, so that's the value of our sides here. Okay, and if you want to know the perimeter, since there are 4 sides, you just simply multiply that by 4. So you get that the perimeter of square, okay, of square CILA is 20 square root of 2, okay, 20 square root of 2 inches. Okay. Very simple. Okay, so for our third problem, we have here a rectangle prom and rectangle PHSR. And the rectangle prom is actually the floor plan for Mrs. Reynaldo's villa. So it's a rectangular shaped building. It's a villa, so it's big. Okay, so that's the rectangle. And then there's a large dining hall to the left side, so it's labeled as PHSR. And we have 2 measurements here. We have the measurement of side PR, or the length is 2t plus 4, and the width of the rectangle, of the bigger rectangle, RM, side is 70 plus 17. And we also have the diagonal of the smaller rectangle of PHSR. It's 25 meters. So the first step that we have to do, guys, is we have to first solve the value of RS. Okay, so how do we solve for the value of RS? Okay, since it's given here that RS is half the measurement of side PR, then we can say that since side PR is 2t plus 4, then we can divide that by 2. Okay, so we can divide 2t by 2 and 4 by 2. So side RS, since it's the half, it says there it's the half, so side RS actually measures t plus 2 units. Okay, and then we can now solve for the value of this angle of this side. Okay, now guys, we're going to try to find the value of t by using the Pythagorean theorem again for solving for the measurement of t. Since we know, okay, that this side PR is parallel to side HS, since they are rectangle, since PHSR is a rectangle, then we can say that we have already formed a triangle right there. So this one measures 25, this one measures 2t plus 4, this one, and this one at the bottom measures t plus 2 from the one that we solved a while ago when we have 2t plus 4. So our formula is going to be a squared plus b squared is equals to c squared. So that's the Pythagorean formula. So we have here a squared, so that's going to be t plus 2 squared plus b. Okay, so what's the value of b? It's 2t plus 4 squared is equal to the value of c, which is 25 squared. Okay, and now we can solve for that neatly. So what's t plus 2 squared? So that's going to be t squared plus 4t plus 4. Okay, and what's the value of 2t plus 4 squared? Okay, that's 2t plus 4 squared, so that's going to be plus, okay, so that's going to be 4t t squared, okay, and then 4 times 2, so that's going to be 8t, plus 2 times 2, so that's going to be plus 16t, and then 4, if we square that, okay, so that's going to be plus 16, okay, is equal to, what's 25 squared? 625. Next is we have to add all of our variables and constants here, or perform algebraic operations. So that's going to be t squared plus 4t squared, so that's going to be 5t squared, and then 4t plus 16t, so that's going to be 20t plus 20t, and then we have 4 plus 6, so that's going to be 20 plus 20 is equal to 625. So we're going to close in and solve for the value of t. So that's going to be 5t squared plus 20t, okay, plus 20t minus 605 is going to be 0. And if you use the quadratic formula, you're going to find the value of t. And the value of t is going to be, okay, so the value of t is going to be negative 2 plus or minus the square root of 5 square root of 5. And since the value of t must be positive, we're going to discard the negative sign here. So the value of our t is going to be negative 2 plus 5 square root of 5. Okay, so now that we solve for t, we can now substitute that on our problem. Okay, so having solved the value of t, which is equal to negative 2 plus 5 square root of 5, we can substitute the value of t here, the one that we have here, to 2t plus 4, so that's going to be 2 times negative 2 plus 5 times square root of 5 plus 4. So the value of segment PR is going to be n square root of 5, and the value of 31 of 7t plus 17 is going to be 31 plus negative 35 square root of 5 when we substitute t to 7t plus 17. Okay, and then the value of rs, of course, we're just going to divide that by 2. So we're going to divide 2t plus 4 to 2, so we can get the value. So the value of 2t plus 4 is 10 square root of 5. When you divide that by 2, you're going to get 5 square root of 5. And then to solve for the perimeter of rectangles PRMO and PHSR, we simply have to use the formula 2L plus 2W. So that's going to be 2 times 10 square root of 5. So they stay the same because they have the same length. So if you see here on this rectangle here, they have the same lengths, but their widths differ. So since PRMO is bigger, so it's going to be negative 31 plus 35 square root of 5, and then for PHR it's going to be 5 square root of 5, and therefore we get their values. The perimeter for rectangle PRMO is 149.25 meters, and the perimeter for PHSR is 67.08 meters. Okay, so for our fourth problem, we want to find the circumference of a circle that's been inscribed in a square. So to solve this, okay, we have here the measurement of the side of the square, that's 2s minus 2 centimeters, and we have here a clue. So our clue here is that s, okay, the value of s is half the measurement of 2s minus 2, and that's also the case here since these points touch here, okay, so they're tangent. Therefore this side must be the half of 2s minus 2, and that's the radius, okay, the segment. So what's 2s minus 2 divided by 2? Okay, so that's going to be s minus 1. Okay, so 2s minus 2 divided by 2, so that's going to be s minus 1, and that's the measurement of the radius, that's r. Now we want to find the measurement of the circle of s. So it says here that s is the circumference of the circle. So the circumference of the circle is equal to c, and that's equal to 2 pi r. Then we can simply substitute this formula. Okay, so since s is equal to c, then we can equate that s is equal to 2 pi r. And what's our r here? So that's s minus 1. And therefore, we can now solve for the value of s. Okay, so now we have the formula s is equal to 2 pi times s minus 1. Then we distribute 2 pi to the term that we have here. So that's going to be s is equal to 2 pi s minus 2 pi. Then we just have to transfer s here and then transfer negative 2 pi to the other side so that we can factor. So that's going to be 2 pi s minus s is equal to 2 pi. And then the factor of 2 pi minus 2 pi s minus s is going to be s times 2 pi minus 1 is equal to 2 pi. And therefore, we can now get the value of s. And that's also the circumference. So the value of the circumference and the value of s is 2 pi minus 1 over, okay, or if we try to simplify 2 pi minus 1 over 2 pi, that's going to be 1.19 centimeters. Okay, so that means this is the circumference of the circle that we have here that's been inscribed in a square. Okay, so now solving for the so we have a regular polygon here and we want to know its perimeter. Okay, so given the side NP is equal to 4p minus 9 meters, so the formula is equal to P is equal to N times S, where N is your number of sides and S is the measurement of the length of the side. So for this polygon or the pentagon that we have here, it's 4p minus 9. But we need to find the value of P. Okay, so we have here a problem. So Antonio has a pentagon-shaped tree house and its perimeter is 215 meters. So we need to find the measurement of each individual side. So to get that, we need to solve for the value of P. So how do we do that? Since we know that the perimeter P is equal to N times S and we know the value of P, which is 215, then we simply have to multiply the number of sides that we have, which is 5, times the side measurement, which is 4p minus 9. And therefore, we have our formula. So 215 is equals to 20p minus 45. And so we're going to transfer 45 to the other side. So that's going to be 215. Okay. Okay, so that's going to be 215 plus 45 is equal to 20p. Okay, and then if we add this, it's going to be 260 is equal to 20p, and if we divide 20 from both sides, we get that the value of P is, okay, so the value of P is 13. And if we substitute this value of P here for the measurement of side NT, we can get the measurement of side NT. So we have here 4p minus 9 is equal to 4 times 13 minus 9. Okay, so what's 4 times 13? Okay, minus 9. So that's 43 meters. Okay, so that means the measurement of side NT and also all of the other sides that we have here, TA, AP, PE, and EN, the measurements of those sides is also 43 meters because it's a regular pentagon or a regular polygon. And then lastly, we have here for irregular polygons for solving for word problems involving perimeter. We have here an irregular polygon. So we want to know the measurement of the perimeter of the staircase. So it's a staircase in the Malacañang Palace, a cross section of the staircase, and Mr. De La Cruz wants to know the perimeter of this cross section of the staircase. So we're given here the measurements, okay, and you can see a lot of congruent sides. So OS is congruent to SR, is congruent to MR, so on and so forth until you reach the bottom. Okay, so the first clue that we need to see here, guys, is that we have here 35. So you see here 35. So the 35 meters is the measurement of segment WT, and it's parallel to OS because OSTW is a rectangle, or SWT or SWAT is a rectangle. So therefore, the measurement of OS is 35, and also the measurement of these other sides here, the 10 other sides here, their measurement is also 35 meters. So we've already solved for 10 sides. So we only need to solve for 2 more sides. Okay, so we have here W minus 1. So that means the measurement of this of each of these sides is going to be 35, okay, minus 1, so that's going to be W minus 1, okay, so that's going to be the formula for that, okay. The formula for that is W minus 1 is equal to 35, and therefore we just only have to transpose 1, so the W is equal to 36, okay. So that means, okay, the value of W is equal to 36. So why is this important? Because that's the value that we're going to substitute to solve for the value of 3W plus 32. So that's going to be 3 times 36 plus 32. So that's going to be 3 times 36 is 108 plus 32. Okay, that's going to be 140. So the measurement of side TF is 140. Okay, the measurement of side TF is 140, and the measurement of WT is 35. Therefore, the measurement of side WF is 175, because we just added 140 and 35. Now we only need to find the measurement of OW. So to get that measurement, as you can see here, we can see here that this thing, this segment, this segment, this segment, this segment, and this segment, if you add the measurements of those 5 segments, you get the measurement of OW. So that means we just simply have to multiply 35 by 5. Okay, so 35 times 5, okay, so 35 times 5, that's the measurement of OW. Okay, so 35 times 5, that's going to be 175. That means OW measures 175. So as we said, we have already solved for the measurement of OW is 175, and WF measures 175 meters as well. And then we have the 10 congruent sides, so the measurement of one congruent side of side OS is 35, so you only multiply that by 10, so 35 times 10, that's 350. And if we add all of the measurements to get the perimeter, OW plus WF, that's 350, so 175 plus 175 is 350, and if you add that to the 10 congruent sides, so the perimeter of this irregular dodecagon, okay, so it's a 12-sided figure, is 700 meters.